In this short video, we'll look at the 4 basic types of problems you can do with normal distributions and show how to solve each of them. So the first one, at a store, the sales follow a normal distribution with mean 250, standard deviation 30, and you want to know what proportion of the sales are for less than 300 or more than 300. In the second one, you've got the same basic data. You know the mean is 250, standard deviation 30, but you want to know how big a sale has to be in the top 2%. This third one is a little different. This time, you know the standard deviation, and you know that the cutoff for the bottom 10% of sales is $300, but you want to know the mean. That's what's the unknown here, is the mean for the store. And finally, in this last one, you know the mean this time, and you know the cutoff for the top 5% of the sales, but it's the standard deviation you don't know. So those are the 4 basic types of problems. Let's do them one at a time. So here's our z-score formula. Sales that buy more follow a normal distribution with mean, oops, that was not that one. Here we go. Sales that buy more follow a normal distribution with mean 250 and standard deviation 30. What proportion of sales are for less than $300? Well, we need to find the z-score that goes with 300. Let's have Excel calculate that for us. The z-score, so equal tells it we're doing a calculation. And we could do this on a calculator too, of course. You take 300 minus the mean of 250 divided by the standard deviation of 30. Hit enter, and there it is. The z-score is 1.6667. So how do we find the proportion of the standard normal distribution, which is less than 1.6667? Well, the Excel function is norm.s.dist. So the z, I'm just going to round the z at 1.67. Cumulative is true. You'll always use cumulative equals true when you're doing these problems. Always. It's not like the binomial. Hit OK, and there it is, 0.95. So 0.95 is our answer, or 95%. And so, of course, if 0.95 or 95% are less than 300, then there must be 0.05 or 5% more than 300. So if you know the x, in this case the 300, and you want to find a proportion or percentage, calculate z, use norm.s.dist. What if you want to go backwards? How large are the top 2% of sales? Well, for this one you're going to use norm.s inverse. If you're in the top 2%, then there's 98% that's less. So we go to norm.s inverse, put in 0.98, and norm.s inverse of 0.98 says that if you're in the top 2%, your z-score is 2.05. So now we get an equation we can solve. Here's the z-score formula, but if you're in the top 2%, z is 2.05. So we get the equation 2.05 equals x, that's what we don't know, minus the mean, 250, divided by the standard deviation of 30. And when we solve this for x, we get that 2.05 times 30, multiplying both sides of the equation by 30, equals x minus 250. Now add 250 to both sides, and we get 2.05 times 30 plus 250 equals x. And let me have Excel do the calculation for me. Obviously, use a calculator would be even easier. 05 times 30 plus 250, and 311.50 equals x. So the answer to our question, $311.50 is how large an order has to be in the top 2%. So going backwards, when you know the percentage, you use norm S inverse to find the z and then solve for whatever you need. One thing to remember here, that norm S inverse takes the percentage less than the number you're looking for, and so I had to put in not 2% but 0.98 or 98%. This is why you always draw a picture so you don't make mistakes there. How about this one? The cutoff for the bottom 10% of sales is $300. What's the mean? Well, again, we'll use norm S inverse. And for the bottom 10% of sales, that means we're going to put in 0.10, and we get negative 1.28. So now the z-score is negative 1.28, and again we get an equation. This time, negative 1.28. We don't know the mean this time, but we do know that 300 is in the bottom 10%, and the standard deviation is 30. So we get this equation, negative 1.28 equals 300 minus the mean over 30, and when we solve that, it becomes the mean. Oh, and let's get the symbol for the mean. We get the mean equals 300 plus 1.28 times 30. So I'll let you do the algebra to convince yourself that this becomes this. And plug that into Excel to find out what it actually is. We get $338. So if $300 is in the bottom 10%, then the mean must have been $338.40. So that's if you don't know the mean. Last problem. What if it's the standard deviation you don't know? Well, this is the cutoff for the top 5% of sales. So to find the z, if you're looking at the top 5%, there must have been 95% less than that. So once again, we go to norm S inverse. Put in 0.95. And this time we get 1.64. So the z-score for the $140 must have been 1.64. So what equation do we get? Well, 1.64 equals 140, that's in the top 5%, minus the mean, that's 90, over the standard deviation. And now this time it's the standard deviation we don't know. Well, when we do the subtraction, that becomes 1.64 equals 50 over the standard deviation. And when we solve that equation, so to solve that equation, you're going to multiply both sides by sigma. And to do that, or when you do that rather, you'll get, let's get our symbols here, you get sigma times, you'll get 1.64 times sigma equals 50, or dividing both sides by 1.64, you get sigma equals 50 divided by 1.64. So let's figure out what that is. 50 equals 50 divided by 1.64, $30.48, almost exactly what it was before, in fact. Standard deviation, $30.48. So if you know the x, the mean, and the sigma, you can find z and you can find proportions. Or if you know the proportion, you can work backwards and find any of the x, the mean, and the sigma. I hope this helps.